In this lesson, we are going to work with the sine law, and we're going to be able to find different sides and angles of a triangle using the sine law. So with the sine law, you do not have to have a 90-degree triangle. You don't have to have a 90-degree angle in any of the three angles in a triangle. This will work on any triangle. So we need to start with labeling the triangle. Our angles are labeled with capital letters. So here we have angle A, B, and C. To label the sides, directly across from angle A is side A, and sides are labeled using lowercase letters. That is the same with angle B. Directly across from angle B is side B, labeled with lowercase b, and directly across from side C, from angle C, is side C, labeled with a lowercase c. So in the sine law, we have a proportion that we can set up. So we have side A over sine A, which is the same as side B over sine B, which is also the same as side C over sine C. So for a sine law, we only need to use two of these at a time. We don't need to work with all three of them. We only want to work with two at a time. In this example, we want to determine the value of B, so lowercase b, which means the side B, to the nearest tenth of a meter. So that's 1 decimal place. So what we're looking for is side B. We want to figure out how long that is. So we need to have another angle and side that we already know so that we can create our proportion. So here we have angle A of 80 degrees and side A of 12 meters. So we're going to start with that. We're going to have side A over sine A, and this is going to equal side B over sine B. So we're going to substitute in what we know. So we know that the lowercase a is 12 meters, and we know that angle A is 80 degrees. So we'll have sine of 80 degrees. We don't know what B is, but we do know that angle B is 55 degrees, so we'll have sine 55. Now that we have the information in our proportion, we need to solve this to figure out what our B value is going to be. So on our calculator, we have to make sure that our calculator is in degrees. So you should have a D or a DEG at the top of your calculator. And we're just going to calculate sine 80 and sine 55. So we're going to have 12 over sine 80 is 0.9848. We're going to round it to 4 decimal places, so 4 numbers after the decimal. On this other side, we'll have sine 55, which is 0.81915. So we'll round that up to 2. So now what we want to do is to cross multiply. So the denominator of the first ratio gets multiplied with the numerator of the second ratio. So we'll have 0.9848 times B, and this is going to equal 12 times 0.8192. So now I'm going to multiply. So on the first side, I'm not going to do anything yet. Now I'm going to multiply 12 times 0.8192 to get to 9.8304. Now, the last thing I want to do to find the value of B is to divide by 0.9848. So on this first side, those two values are the same, so they divide out. And on this right-hand side, when we divide this, we get an answer of 9.98. And the question says round it to the nearest tenth, so that would be 1 decimal place. So the 8 actually bumps the 9 up to a 10, which then in turn bumps this up to 10.0. And we know that we're working in meters. So the length of side B, right here, is 10 meters. In this next example, we want to determine the value of A to the nearest tenth of a meter. So lowercase a means we're working with a side. So we want to find this side here. So now we know that we have angle angle A that matches up with side A. But we also need either angle B that will match up with side B, or we need side C that will match up with angle C. And unfortunately, we don't have either of those. So we need to be able to find one. It's not possible to find side C using the information that we have, but it is possible to find angle B because we already have two angles in this triangle. And we know that 3 angles in a triangle always add up to 180 degrees. So angle B we will find by taking our 180, subtracting 46 degrees from angle C, and subtracting 53 degrees, that's angle A. So when we do that, we'll end up with 81 degrees. So now we're going to use A over sine A equals B over sine B. So A is the value that we're looking for, and our capital A is the angle A, which is 53 degrees. So we'll have A over sine 53, and this will equal side B of 36 over sine of 81. So again, to start, we're going to determine the decimal value of sine 53 and sine 81. So sine 53 is 0.7986. Sine 81 is 0.98768. So we'll round that up to 77. Again, we need to cross multiply. So we'll have A times 0.9877, and this will equal 36 times 0.7986. So we want to multiply out our left-hand side. So when we do that, we'll get to 28.7496. The last step we need to do is get our A value by itself, so we'll divide out 0.9877 from both sides. These values will divide themselves out and we'll just be left with A. And when we divide the right-hand side, we end up with an answer of 29.1. And we're working in centimeters. So 29.1 centimeters is the length of side A. In this next example, we are not given the diagram of the triangle, but we are given information about the triangle. So it says in triangle ABC, angle A is 57 degrees, angle B is 73 degrees, and AB, so side AB, is 24 centimeters. Now we want to find the length of side AC. So I'm just going to draw a basic triangle. It doesn't need to be drawn to scale. I'm going to label this with A, B, and C because those are the letters that we've been given in our triangle. And I'm going to put the information onto the triangle that I know. So angle A is 57 degrees. Angle B is 73 degrees. We don't know what angle C is. We know that side AB is 24 centimeters. And we're trying to find the length of AC. So in order to figure out or to use the sine law, we need matching sides and angles. So we're looking for side B, and we also have angle B. So that's good. We have angle A, but we don't have side A over here. And there's no way that we can find side A, so it's not possible to use angle A and side A. So we will have to use angle C and side C of 24 centimeters. So first we have to find angle C. And again, we know how to do that. We'll take 180 degrees, subtract 73, and subtract 57. So when we do that, we end up with 50 degrees. So angle C is 50 degrees. So now we can set up our sine law. So we will have B over sine B equals C over sine C. Next, we're going to substitute in the information that we know. So we're actually looking for side B. Our question mark is side B. So we'll have B over sine 73 equals side C is 24 centimeters over sine of 50 degrees. So again, I'm going to start by figuring out the decimal value of sine 73 and sine 50. So we'll have B over 0.9563 equals 24 over 0.7660. So now we're going to cross multiply. So I'm going to have B times 0.7660. And then I'm going to multiply 24 times 0.9563. And I'm just going to multiply this right now. 24 times 0.9563 gives us a value of 22.9512. Now the last step is to get the B value by itself, so we're going to divide by 0.7660. And when we do that, we figure out that side B is 22.96 centimeters long. It doesn't tell us what to round to, so I will use 29.96. You could also round that up to 30 centimeters. In this example, Toby uses chains attached to hooks on the ceiling and a winch to lift engines at his father's garage. The chains, the winch, and the ceiling are arranged as shown in this triangle. Toby solved the triangle using the sine law to determine the angle that each chain makes with the ceiling to the nearest degree. So he claims that theta is 40 degrees, so this angle here is 40 degrees, and he says that alpha is 54 degrees. So we need to figure out if he is correct. If he's not correct, then we need to make the corrections. So on this one here, we're going to start by checking angle theta. Okay, I'm just going to label this triangle A, B, and C. So we'll have side A as 2.8, side B is 2.2, and C will be 1.9. So I'm going to use A over sine A because we have all of that information. We have the side length as well as the sides of the angle. And because I'm figuring out angle theta, that's going to be B, I'm going to have B over sine B. So now substitute in what we know. So A is 2.8. Angle A is 86, so sine of 86 degrees. B is 2.2 over sine B. So this time we're actually looking for an angle. So again, I'm going to change sine 86 to a decimal. So we'll have 0.99756, so we'll round that up to 76. I'm going to cross multiply. So we're going to start with 2.8 times sine B. And then I'm going to multiply 2.2 times 0.9976. And I will get to 2.19472. Now I'm going to divide out the 2.8 from both sides. And when I do that, we will get 0.7838. And now with sine B, we're actually looking for the angle this time. So in order to find the angle, we need to use the inverse sine. And in order to do that, we use the second or shift button on our calculator. So when we do that, we find that angle B is actually 51.6 degrees, or let's round that up to 52 degrees. So Toby is not correct in his calculations. He said that angle B, or angle theta, was 40 degrees when we've calculated it out to be 52 degrees. So that also means that angle alpha is also incorrect. So I'm going to change what he's done. So we know that angle B is actually 52 degrees. In order to find angle C, we will just take our 180 degrees, subtract the 52 degrees, and subtract the 86 degrees. And we'll end up with 42 degrees for angle C, or for angle alpha.